What if everything you knew about structural frames was incomplete? In this session, I will talk about most common misconceptions about roller, pin, and fixed support. I will walk you through a real-life structural frame example, showing you not just how to draw shear force, bending moment diagrams, and deflected shapes, but why and how most common and conventional approaches get it wrong. This is the qualitative analysis they should have taught you in engineering school. So get your pen ready and let's get started. Hey friends, if you're new here, I am Dr. Jawed Qureshi, a senior lecturer in structural engineering and design at University of East London. On this channel, we explore structural engineering. In this problem, we have to draw the correct deflected shape, and EI is constant. And additionally, I will draw the shear force and bending moment diagram as well. Let us assess these options. We have a central point load applied, and the beam should deflect like this. This is absolutely fine. When this column is moving towards right, then what is stopping this column from moving right? And this will not bend like this, so this option is incorrect. For solving the question, I will be applying these three golden rules. The first rule is rigid joints will remain at 90 degree. For example, there is a rigid joint over here. When you are applying load at the tip, the 90-degree angle, which is here, it does not change at all. It will remain 90 if the joint is rigid. The second rule is that fixed support will have zero rotation. This is a fixed support. Theta over here is going to be 0. So slope or rotation at a fixed support will always be 0. Thirdly, internal pin does not take any moment at all. So here we have internal pin. Moment is always going to be 0 at internal pin. And option B is incorrect as well, because this is a typical behavior when you have fixed support. So a slightly modified behavior, obviously. Rotation is going to be 0 in case of fixed support. And here the roller support is not moving. When you apply loading, it should move outwards. So for this reason, this option is incorrect as well. And slightly modified version would be that if you have fixed support, then it cannot move in any direction. But here we have a roller, so roller has tendency to move in horizontal direction. And remember that these deflections are highly exaggerated. These are enhanced. In real life, this is not going to happen. It will certainly be in a 5-meter column. The deflection is going to be probably 5 millimeter or less than that. This is highly exaggerated. Let me move to option C. Now here, this option looks promising to me because when you apply loading, tendency for this frame is that it will move towards right because of this roller support. And when this is moving towards right, it will bring in column C to move towards right as well. And certainly it will not bend because we have 0 horizontal reaction over here. If the horizontal reaction is 0, it means that this pin support will not have any reaction as well. So when it doesn't have any reaction, it means that this is not going to bend. When we have reaction, then it will bend. And then I move to option D. In option D, you can see that left column is bending. That means that this is incorrect. It will not bend because horizontal reaction is 0. Let's now draw the deflected shape. Once deflected shape is drawn, then I will draw the reaction. So direction of tension is here, sagging only, upward reaction. There is no horizontal reaction. So when there is no horizontal reaction because it's a roller support, then we will not have any horizontal reaction over here at pin support. Pin support will normally have a reaction, but here because horizontal reaction is released at a roller support, so that's the reason we will not have any horizontal reaction at pin support. So these are the sign conventions which I will be using. Anti-clockwise shear forces are positive. Tension, it means that arrows pointing away from the element will be positive, and clockwise moments from left are positive, from right anti-clockwise moments are positive. And for bending moment diagram, sagging moments are drawn inside the frame, and hogging moments or negative moments or anti-clockwise moments are drawn outside the frame. Reverse is the case for shear force diagram, when we will draw the negative forces inside and positive forces outside. Remember that anti-clockwise shear forces are positive. Anti-clockwise shear force is like this. It will generate anti-clockwise moment and it has to be drawn outside the frame. Now, how do we draw its bending moment diagram? It's very simple. We have a point load applied, so bending moment diagram will only be in sagging. So remember, we draw negative moments outside, and the reactions are like this. And remember that in case of shear force, we draw negative inside and positive outside. So starting from right side would be our best option. So from right to left, it's creating anti-clockwise. So anti-clockwise is drawn positive. And then this reaction, not reaction, this load will bring it down. And when we'll bring it down, then after that we have left force and we have downward reaction. It is creating a clockwise shear force. So clockwise shear force will be drawn on negative side. So this is how we draw shear force diagram. The correct option is option C, where columns are not bending. Bending is only happening in beam. Now this is a very non-typical question, and let us see how I can draw the deflected shape and bending and shear force diagram. Let us first of all assess option A. In option A, because there will be a horizontal reaction at a roller support, so this cannot move, the column cannot move in leftward direction. So that's the reason this option is incorrect. And then I will move to option D as well. Option D is incorrect as well, because when we are applying loading off center over here, this will not cause the shortening in the columns. The shortening will not happen. So that's the reason this option is incorrect. So when we apply loading over here, see that it's off center point load. And when we apply loading, this should have tendency to go slightly up and then slightly down. And here it is bending like in single curvature. So single curvature will not happen. And also this looks pretty much straight line. So option B and C are pretty close, but I will take it as wrong because only single curvature is happening. Option C is the right one because here double curvature is happening. So we have tension here, and that makes sense. If you pull this down, it will try to bend it at this point. Over here, because we have a fixed support, so it will try to move it up. So that's why we have tension on that side. So a single curvature is happening in the column, and we have tension on this side. So let's see how we can draw the bending moment and shear force diagram as well. First, the deflected shape. Option C is right. The entire vertical reaction is taken by right support. And first, let us see where we have tension. We have tension here, we have tension here, and we have tension over here. A single curvature is happening on left column, so that's why reaction is going to be leftwards. And moment causing this reaction is anti-clockwise moment. Anti-clockwise will cause tension over here. Then reaction at right side is going to be rightwards. Let's first of all draw the bending moment diagram. Firstly, we have tension inside over here. So I will draw this. Positive is drawn inside, negative is drawn outside. Between point load and the end, moment is not changing because we don't have any vertical reaction. And between point load and this point, a double curvature is happening. This is trying to bring it down and this is going up. And at the end, we have single curvature, and then the direction of moment is in the same direction. The reaction moment is in the same direction as upwards. So this is how we draw the bending moment diagram. Then I will draw the shear force diagram. Shear force negative is drawn inside, positive is drawn outside. Remember that anti-clockwise shear forces are, sorry, this is rightwards, not leftwards. And this rightward force will create an anti-clockwise moment, not moment, anti-clockwise shear force. So anti-clockwise shear force is drawn on the positive side. So I will draw it here. I don't have any vertical reaction. So between point of applied load and between the end, I don't have anything. Between this point load and the reaction, it is causing clockwise. So clockwise is drawn as negative. And then this reaction is leftwards. It is causing a clockwise moment. So clockwise is negative. So negative is drawn inside. So in this way, we drew shear force bending moment diagram and deflection shape. The correct option is option C. You can now watch the entire video series on ISTRAC-T certificate in structural behavior by scanning this barcode or going to this URL. It's very useful playlist to watch, and if you want to clarify your basic concepts, watch this series now. You can download the lecture slides by scanning this barcode or going to this URL. And don't forget to subscribe and like the video if you think it added value to your knowledge and understanding.